Here's a quick video for those of you who want a little bit of extra help on the 1.6 Delta Math assignment, finding limits algebraically. So I'm just going to go through and probably do 2 examples from each of the sections. In this first section, we're looking at piecewise functions, and so we are going to have to look at the left-hand and right-hand limits. So it says determine the limit of f of x as x approaches -1, and since that's the breaking point of this piecewise function, I'm going to go ahead and solve this top limit and then solve the bottom limit, so that'd be your left and right hand limit respectively. So if I go ahead and plug in -1 into this top equation, because that would be for values less than -1, so that would be my left hand limit, you would get -4 minus 2 times -1, so -2 times -1 is a +2, and -4 plus 2 would be a -2 overall. I'm just going to write that down here so I don't forget. And then for this bottom limit, because that would be our right-hand limit for x values greater than -1, greater than or equal to -1, excuse me, I'm going to go ahead and do the same thing. So if I plug in -1 here, -1 squared is 1, -2 times 1 is -2, and so 4 minus 2 is a +2. Since those don't match, then technically my general limit would be D and E. So I'm going to go ahead and delete that. Right, D and E. Voila. If you don't like my explanation for it, regardless of whether you answer a question correctly or not, you can always go through and look at the solution they gave you as well. So they talk about the left and the right hand limits, using which piece of the equation for which limit, and then because they don't match at the end, D and E. They'll also usually provide a graph so you can kind of see visually what's going on. All right. Let's try one more of that one. So in this problem, it wants me to determine the limit of the function as x approaches -3. It just wants the right-hand limit. So I'm only going to look at the piece of the piecewise function that has values greater than -3. And so that would be the top part of this piecewise function. And so I'm just going to go ahead and plug this -3 into the equation. So -3 squared is 9, but this negative was also just hanging out front. So -9 plus 9 is 0. And that would be my final answer for that one. Voila. And again, they go through it step by step, kind of show you what everything's all about. All right, let's go ahead and move on to the next section. This one you're probably going to need a little bit of scrap paper for. So in this equation, it says determine the limit shown below in simplest form. So the first thing you always try to do is you always try to just plug in the value that x is approaching. But I'll notice here that if I plug in 0 in for all my x's, I end up with 0 minus 0 over 0 minus 0. So I would end up with an undefined form. So now I'm going to try and factor. And I just have a Canvas pulled up so I can work on this. So let me see, x squared minus 8x over x squared minus 3x. And I'm doing the limit as x approaches 0. X squared minus 8x, x squared minus 3x. And so like I said, if I plugged in 0 into all those bits, you'd end up with 0 over 0. So the next thing you can try and do is you can try to factor. So now we're going to find the limit as x approaches 0. And if I pull out from the top a GCF of an x, so that means an x can come out front, and I'll be left with an x minus 8 inside. And then on the bottom, same thing, pull out that x, and you have an x minus 3 left over. And so now what we can do is you can cancel out those x's. And so now I'm just going to really be dealing with the limit as x approaches 0 of x minus 8 over x minus 3, which would be, plug in 0 for both those x's, -8 over -3, or when those negatives cancel, 8/3. Cool. So I can go ahead and plug that in. Lovely. And it goes through the steps for me. All right, let's try one more problem. Go back and clear off my canvas. I might have to work again on this. Don't mind my mess. Okay. All right, so let's go back and look at this delta math. So it says determine the limit shown below in simplest form. So limit as x approaches -4, and I'm going to go ahead and first and foremost to see if I can plug into this one. This one looks a little bit trickier to plug into though, so maybe I'll work it out on my canvas up over here. So negative 5x minus 35. So let's see, limit x approaches negative 4. On the top I have negative 5x, whoops, minus 35. And then on the bottom, what did I have? X squared minus 4x. So x squared minus 4x. Cool. All right, so now I'm going to go ahead and just plug in that negative 4 everywhere that's in here. So negative 5, let's see, negative 4 minus 35 all over negative 4 squared. Okay, so let's see, negative 5 times negative 4 is positive 20. 20 minus 35 gives me a negative 15. On the bottom, negative 4 squared is 16, and negative 4 times negative 4 is another 16. So, oops, 16 plus 16 more would be 32. Yeah, that seems right, right? All right, that's good. That's great. That's what I'm trying to do. So I'm gonna go just plug in negative 15 over 32 and see if that's my answer. There we go. Sometimes you'll notice that they probably started the problem that a lot of the ways that you guys will, you'll see stuff that looks like it's factorable. And so you'll all of a sudden want to just start factoring everything. But that's why I remind you that the first thing you should always try is just to plug in the number, because they factored unnecessarily and nothing ended up canceling. And then they plugged into their factored form, but you don't even need to do that, as we can see up here, right? The first thing I always try is just to plug in that negative 4 everywhere it belongs, and you get an actual answer. So like I said, follow those kind of steps that I provided in the notes, and you will hopefully have no problem. So let me know if you have any other questions about this assignment.